Then we have the next ones. Once again, we're going to fast forward these. Average speed versus average velocity. So you see, in most of the cases, you're not moving with uniform velocity. I mean, 99% of the cases, your velocity changes. The speed also changes, the velocity also changes, and the change in velocity can be due to the change in direction as well, even if your speed is constant. But if you change the direction, even if a little bit, half a degree, your velocity would be changed. And matter of fact, most of the examples of the uniform velocity you find in the physics problems only. There are some examples, for example, the free falling body, those kind of examples, but most of the cases in our everyday life, we move with different speeds. So, how do we find a certain speed if your speed changes throughout the journey? We use this term, we call it average speed. So, you might be covering the track, you might be covering the distance at different speeds throughout your journey, and we can find the average speed of it. How do we do that? We have a very simple formula for this, that average speed equals to, written as V average, and that equals to total distance divided by total time. Total distance divided by total time. Likewise, average velocity can be written as total displacement divided by total time. And the next properties of average speed and average velocities are same. For example, average speed is always positive, average velocity can be positive and negative, and even if an object is moving, the average velocity can also be zero if the object returns to the same point. So average speed would always be greater than average velocity in terms of magnitude. And keep it in mind, when an object is moving in a circular path, the direction of the velocity changes at every point. So think about it. If the object is moving in a circle, even let's say the object is moving with constant speed, 10 meter per second. But the speed might be constant, but the velocity is not constant, because the velocity includes the direction as well. At this point A, the velocity is tangent to the circle. At this point B, the velocity is once again tangent to the circle, but the direction is different now, because tangent to the circle at this point is downward. At the point C, the velocity is tangent to the circle. So the direction of velocity changes at every point. Hence, during a circular motion, an object cannot have uniform velocity. It always has some acceleration, because it experiences a resultant force that is towards the center of the circle. We call this centripetal force, and we study that in detail in A2 physics. The word centripetal itself is just an adjective. It's just a nickname, a special name. It can be given to any force that makes an object move in a circular path. So centripetal force itself is not a force. It's an adjective for a force that makes an object move in a circular path. Let's move on to the next one. Going to fast forward this. Acceleration is how fast your velocity changes. So the change can be positive, change can be negative. If your velocity is being increased, we say you're accelerating. If your velocity is being decreased, we say you're decelerating. So deceleration is basically a certain kind of acceleration. And when we say the word acceleration, it can refer to both of them. For example, when you use the word a man in our everyday life, and we use a word, he is a man of his words. We might be referring to a female as well. So man is just is being used as a general word to reflect the entire species. So acceleration is rate of change of velocity or change in velocity with respect to time. When you use the word rate of change, it already means with respect to time, at least for your syllabus of A-level physics. In higher physics, the rate can be with respect to the change with respect to some other things as well. For example, change with respect to area, change with respect to force, and these kind of things. So how quickly you speed up or slow down, that is the acceleration. For example, I always give this example to the student. Think about it. A motorbike and an airplane, they are in for a race, and they race for they set up for a 100-meter race. A motorbike and airplane. So you have motorbike here, you have airplane here. Okay, they set up for a race, and all we gotta do is we're going to find out which one would be faster in the first 5 seconds, and both of them were initially at rest, so their initial velocities are 0 for the motorbike and for the airplane. So what do you think? In the first 5 seconds only, in the first 5 seconds, which one of these two vehicles, the airplane or the motorbike, which one of these two objects would pick the speed faster in the first 5 seconds? I mean, everyone would be able to answer this, that the motorbike, at least for the first 5 seconds, the motorbike would pick up the speed faster. So we can say the acceleration of the motorbike in the first 5 seconds is higher than the acceleration of the airplane in the first 5 seconds. So acceleration has nothing to do with your speed, nothing to do with the speed alone. It tells you how quickly you change your speed with respect to time. Another example is, let's say you have an object A, a car A and a car B. So we start the time from 1 second, then 2 seconds. So your speed of the object A in first second was 10 meter per second, and then after 1 second the speed increased to 15 meter per second. The speed of the vehicle B was, let's say, 120 meter per second, and then after 1 second the speed increased to 122 meter per second. So you see, the object B is moving much faster than the object A. But let's talk about the acceleration. For 1 second, what is the change in speed of or velocity of the object A? Let's assume the speed and velocity are same in such a way that they're moving in a straight line without any change in direction. So what is the change in velocity for the object A in 1 second? There's a change of 5. Now what is the change in velocity for the object B? The change is 2. The velocity increases by 2 units. Which one of these two objects have more increase in velocity over the same interval of time? It is the object A. So although the object B is having higher speed, but the change in speed is not high enough. So acceleration is higher for the object A. Okay, then the SI unit of, and I mean, I also give this example to my students, especially those who are interested in football. Now we always have this debate about who is the better player, Messi and Ronaldo, and we keep comparing their physical attributes and qualities. So they always say this thing, that Ronaldo is a faster player, but Messi is having more acceleration. So although the Ronaldo would be faster over like a large distance, but Messi has more acceleration, which means Messi is able to pick up his speed very fast. So in short bursts, in short distances, Messi would be able to pick up his speed very quickly, which means he is having more acceleration. Okay, so classification acceleration in the vector quantity. SI unit is meter per second square, ms minus 2 or m slash s square. Acceleration can be due to the change in speed, due to change in direction, or due to the change in both speed and direction. And like I said, whenever an object moves in a circular path, even if the speed is constant, the velocity still changes. Why? In that case, the velocity changes due to the change in direction, even if the speed is constant. And if the direction changes, the body accelerates. And for a circular motion, the acceleration of a body is towards the center of the circle. So let us solve some of these sample questions. Here we have the first one. Define displacement. You can define it either way. One of the easier definition is the shortest distance between 2 points, or you can also say distance from a fixed point in a specific direction. If you add a certain direction with the distance, you get the displacement. And then they ask you the next question, use your definition to explain how is it possible for a car to travel a certain distance and yet have zero displacement. So let's say your car starts from here, from point A, the car goes over there, then returns to the same point. The distance would be the length of the entire track, but the displacement would be zero. So think about the race cars. Whenever the race car completes one lap, after every lap, the displacement would be zero. Because completing one lap means you return to the same point, then you start the same circuit again, you start this next lap, and whenever you reach the starting point, your displacement comes out to be zero. Then you need to complete the table in which you have to filter out the scalar and the vector quantities. Distance is scalar, speed is scalar, and acceleration is vector because acceleration is in a certain direction.